In this video series and in this unit, we're starting to talk about trigonometry. Not only just SOHCAHTOA, but starting to look at what they look like on a graph. So why we look at trigonometry? Well, it does connect these trig functions, sine, cosine, and tangent, to their graphs. The other thing is that oscillations in waves, periodic motion, are everywhere, from ocean waves and ripples in water being periodic. Light, as you know, is both a particle and a wave. Music is all about frequencies and how our brain registers them, so all about periodic motion. We'll look at that in a second. And electricity. Everything that runs our modern day life runs off of periodic motion. This is a video about pianos and why they can never be in tune that we'll watch in class. If you aren't going to be in class or want to watch it, it's a minute physics video about how to tune or why a piano can't be tuned. You can also look at the notes in the note section of Canvas, and it'll play directly from there. So by the end of this unit, what you'll be able to do. So you'll need to be able to use the exact values of sine, cosine, and tangent for 30, 45, 60, also 0 and 90 degrees, and any related angles, so any combination of those. You'll need to be able to sketch the graphs of sine, cosine, and tangent. You need to be able to use the inverses of sine, cosine, and tangent. Use our trigonometric identities, our trig identities, to solve and prove problems. And then be able to use your knowledge of solving functions to solve where lines cross trig functions for a given range. Because remember, they are periodic, so there's going to be multiple solutions. So in this specific video, what we're going to look at what is an angle, your trig ratios, the exact values, and the unit circle. So first up, what is an angle? So an angle is simply defined as a measure of rotation of a line segment about a fixed point. Okay. So we have, let me pick a different color here. So we have our line segment. Okay. Angles measured in the positive x direction, so that's where we are, positive x, and anti-clockwise is positive. So clockwise is this way, but positive is anti-clockwise. So as we go around this way, that's a positive angle. It's measured positive angle. If you go this way and measure the angle in here, that's going to be a negative angle. Okay. Our angle made with the x-axis, the acute angle, remember acute being the small angle, made with the x-axis is your reference angle, the base angle, or sometimes called the principal angle. So let's take a look at these two. Part of the questions you're given, we need to find the quadrant in which theta lies and the range. We need to find the value of theta. Okay, so let's think about our circle. So theta is somewhere 0 to 360. So that's from here, 0, all the way around to 360. And our base angle is 55 degrees. So it also tells us theta is in the second quadrant. Remember this, 1, 2, 3, 4 goes around like a C. So we are second quadrant, 55 degrees. So let's think. We know that the whole thing is 180. So theta is going to be equal to 180 minus 55. So theta is going to be equal to 125 degrees. Let's think about letter B. So it's 20 degrees in the third quadrant. So we're in the third quadrant. Principal angle is 20 degrees, but theta is negative. So again, it's 180 degrees here. So theta is 20 minus 180 degrees. Theta is equal to negative 160. So there you go. There's those two examples, and I've got several for you to work in class. Next thing to look at, hopefully this is a refresher, is SOHCAHTOA, sine, cosine, and tangent. Okay? Sine, S-O-H, so, is opposite over hypotenuse, often considered y over r. Because if we think of a triangle, this is going to be x, y, and that's our radius when we think of this point here as the center of the circle. Cosine, or ka, is adjacent over hypotenuse, and then tangent, or toa, is y over x. Okay? Trig ratios have their limit, though. They only work when theta is less than 90 degrees. If theta is over 90 degrees, you're going to get domain errors when using them. That's where that base angle, or the principal angle we were looking at here, comes into play. So for example, if I have this angle, say it's 200, nope, not 200. Let's say it is 120 degrees. I can't put sine of 120 degrees in my calculator. I have to use 60 degrees and work it out. So you have to be careful with what you choose. So here's what I'm talking about. So sine of theta is 1 over 4. So sine theta is 1 over 4. Sine is opposite over hypotenuse, or y over r. So if I think of my triangle, that's theta. This is 1. This is 4. Now I need to figure out cosine. So cosine of theta is adjacent over hypotenuse, or x over r. Well, I know what r is already. It's 4, but I have to figure out this missing side. Well, I know that's a right triangle. So 4 squared equals 1 squared plus x squared. We can use the Pythagorean theorem. So this is 16 minus 1 equals x squared. So x is equal to the square root of 15. So then cosine, the exact value of cosine, is going to be cosine of theta square root of 15 over 4. That's your exact value. Let's take a look at a different one, at tangent of theta. So let's reconstruct our triangle. We know this is 4, this is 1, and this is the square root of 15. And we know that's theta. So tangent is O over A, 1 over the square root of 15. It goes 1 over square root of 15. You might also see this written as that. This right here is what we call a rationalize denominator. Depending on the question in ALEX, it may ask you to rationalize the denominator. So you might see an answer like this. The way we do that is we just multiply by 1. Just like we did when we were looking at complex, kind of like what we did when we were looking at complex numbers. So here's some for you to try. Okay. So the unit circle. Okay, I highly recommend you check out the actual notes so you can go to this Desmos illustration. I'm also going to talk about it in class. The unit circle is how we define trig values. I highly, highly, highly recommend that you memorize the unit circle. That's going to be very useful to you if you don't already have it memorized. But what's important is you need to know the first quadrant. You need to know those values exactly. So you need to know that you need to be able to find that 30 degrees is pi over 6, but you also need to know that that's square root 3 over 2 1/2. That 45 degrees is root 2 over 2 comma root 2 over 2, and then 1/2 comma square root 3 over 2. There is a pattern. If you want to know more about the unit circle, there's lots of videos and creative things out there about what the unit circle is. But it's essentially a circle with a radius of 1 that we use with trigonometry to help us determine the value of trig functions. So let me show you one of the reasons why you need to know the exact values of each function. So sine of 30 from the unit circle we know is 1/2 times cosine of 60 we also know is 1/2. So this evaluates to 1/4. Okay, sine squared of 45 is square root 2 over 2, and it's that function squared. So it's going to be 2 over 4, or 1/2. Okay, I simply used the unit circle and filled in my values. Sorry about that. So signs of trig ratios. So sine, cosine, and tangent are positive or negative in different quadrants. So this chart spells out exactly how we get the positive and negative based on x, y, and r. But the easiest way to remember, there are different acronyms, but given that this is AICE class, I find this particular one the best. It is All Students Trust Cambridge. So what that means is if you're thinking about your Cartesian coordinates, your xy plane, and you're thinking about the quadrants, remember they go around like a C, 1, 2, 3, 4. It's All Students Trust Cambridge. And what that means is all functions are positive in the first quadrant. Sine is positive in the second quadrant. tangent is positive in the third quadrant, and cosine is positive in the fourth quadrant. So remember, all students trust Cambridge. So what we looked at in this video is we looked at what an angle is. We looked at the trig ratios, sine, cosine, and tangent. We looked at the unit circle and the exact values of sine, cosine, and tangent for 0, 360, 45, 60, and 90 degrees. We looked at the signs of trig functions as well, where they're positive and where they're negative. Don't forget your 4 homework problems. I would start these early and often. I would also recommend that if you're struggling with some of this content, to do these problems that are listed here. Right? Extra practice is not going to hurt, and these are not Cambridge style. The additional support are not Cambridge style problems. They're just basic mechanics problems for you to practice using the material.